Passage 4. Page 153. Questions 7 and 8. Listen to part of the lecture in a meteorology class.
Today, I'm going to be lecturing about the theories of William Redfield and James Espy. Now, both of them were American meteorologists in the 19th century. However, they had different ideas about how storms behave, and they each argued for their own models for years. And in fact, it became a wider debate as different groups of scientists in different places lined up behind one or the other of each man's hypothesis. So, for example, at one point, meteorologists from England were supporting Redfield's model, while many of those in France were supporting Espy's. But the real point I want to make concerns how competing models and approaches can sometimes actually be complementary. Okay, so now let me outline the models. Espy argued that centripetal force was at work in storms. Now, as you know, centripetal force would cause winds to move inward from all directions toward the center of the storm. So he was basing this on his hypothesis that storms are caused by rising currents of moist, wet air, or convection currents that form clouds. Now, as the air rises, air is drawn in from all directions. But, as logical as it sounds, this model hasn't proven completely accurate in the case of the biggest and most powerful storms. Now, that brings us to the theory of the other meteorologist, William Redfield. He argued that the winds in a storm rotated around the center of the storm, so the winds would be moving in a circular path. And he believed that the winds moved in a counterclockwise direction. This theory was based on his own observations, especially from a hurricane he witnessed that hit New York City directly in 1821 and also affected surrounding states. He noticed that crops, corn, fruit trees, had been flattened in different directions in different parts of the state of Connecticut, where he was living at the time. So, this led him to believe that the winds were going in different directions around the center of the storm. And he also collected a lot of eyewitness accounts to back this up. Now, it's important to note that Redfield didn't know why the winds were rotating around the centers of the storms. He was basing his assertion on empirical evidence. That is, on what he saw with his own two eyes, not on the results of a hypothetical prediction. This was in stark contrast to how Espy had arrived at his claims for wind direction in storms. And, in fact, this was another point of argument between the two men. Redfield disrespected Espy for relying on his model of storms instead of observation. In any case, Espy believed that centripetal force caused winds to move inward toward the center of a storm, and Redfield believed that the winds in a storm moved in a circular, counterclockwise direction. So, it turns out that Redfield was correct in terms of big storms due to the effect of the Earth's rotation. You see, winds do indeed rotate counterclockwise around the center of the storm. Oh, and incidentally, they go in the opposite direction in the southern hemisphere. However, Redfield wasn't making his observations there. But, and here's where the complexity of meteorology becomes apparent, it turns out that Espy was not entirely incorrect. Winds do move toward the centers of storms because of convection currents. Espy just didn't take into account the effect of the rotating Earth on those inward-moving winds. So, to sum it up, there are a couple of important themes for us to think about here. One is the different approaches towards scientific explanations of natural phenomena. Redfield's emphasis on what he observed and Espy's on what his hypothesis predicted. Another is the idea that sometimes the competing hypotheses that scientists fight furiously over turn out instead to be complementary models. That is, each one can help explain some specific aspect of a process, or the process under certain conditions. So if Espy and Redfield had put aside the desire to win the argument, maybe they would have appreciated this fact sooner.